seconds. And we have a range of speakers to talk about all sorts of things, all to do with Algol 60. We do have 15 minutes discussion scheduled at the end of the day, if we get there, as it were, without overrunning. We have to be out of here by 5:15, which is the Cycles have jumped on as another event they want to put in here, so it's going to be a bit tight. So I'm going to be ruthless chairman, cut people off at that moment. So, and my job is to tell you who's speaking and who they are. So the first one is in fact an interview of Mike Woodger by Brian Richmond. Let me first of all say something about Brian Richmond first. He's described in Wikipedia as a British mathematician and computer scientist. I don't know if you knew that or not. And spent much of his career in the NPL, much involved in software of the KDF9, and he was instrumental in instrumenting the Whetstone Algol benchmark. But he's got a wide range of interests. I learned that he's the editor of the journal Voting Matters, whose purpose is to advance the understanding of preferential voting systems. I'm sure it's a very lively and interesting journal. Mike Woodger, now of course well retired, was a long-standing member of the NPL, and he was described, again in the usual references, as Alan Turing's assistant. He was co-author with Alan Turing of a volume containing various papers by himself and Turing. And this includes Mike's paper on the history and present use of digital computers at the NPL. And about the construction of Pilot 8, I believe. He was involved, of course, in the Algol committee, international committee, the IFIC committee, which designed and developed Algol, not only Algol 60, but for the real purists among us, Algol 58. I was a research student at the time, and I was sent down to NPL to meet Mike, pick his brains, to find out what I could do from my research. And it was just the day after, I think, he got back from Paris in 1960. And I heard it all, what happened in Paris, from Mike's lips, and it was a fascinating story, and I presume we'll hear something of it today. Lately, I hear Mike is active, in spite of his quite considerable advancing years, with the Barnabas Trust, doing missionary work in Kenya and Romania. I think a far more satisfying activity than the development of international programming languages. Brian, we'll go to you.
Can you hear me?
Yes.
Very good. Just to put the record straight, I'm formally no longer editor of Voting Matters. Your successor has yet to be appointed, so if you're really interested in preferential voting, please contact me.
Voted off.
My purpose here is just to interview Mike. I'll just deal with the prepared questions, and then if you have any further questions for Mike, then we can handle that at the end. So Mike, well, when did you start working at NPL? Yes, I think so. I think there's a red light.
Oh, does it work? Yes, yeah. I started working at NPL on the 20th of May 1946.
Which was a lot earlier than I started, which was 1964. So I didn't have the advantage of working with Alan Turing. So Alan Turing was clearly working at NPL at that point. What do you remember of him?
He was very kind. He was also very shy. He seldom looked people in the eye unless he's very close to them. He was encouraging. He helped me tremendously in lots of ways. But the big bond we had in common was a common interest in logic. My father tried to apply mathematical logic to biology. As a natural enough, as soon as I could understand what he was on about, he taught me mathematical logic.
That seems marvellous. Did Alan mention anything about programming languages, or was it a concept that had yet to be formulated?
No, the word programming languages wasn't around.
But that's really rather a shame, because I felt that his insights were marvellous. My favourite remark that I ascribed to him, I don't know if I've got it exactly right, was that coding need never be boring, since anything sufficiently routine can be safely delegated to the computer. I feel these days this is something we've lost, as I repeat for 400 times some click and point operation on my computer. Anyway, Mike, when did you first get involved in Algol 60?
Well, I had to look that up. I attended an international symposium on automatic computing in Darmstadt in October '55. And that was when I met the Rotheshauser, Bottenbruch, and other luminaries. Well then, Bauer wrote for the German Gesellschaft für angewandte Mathematik und Mechanik, wrote to J.W. Carl III for the Association of Computing Machinery. The Germans and the Americans got together in October '57. This letter was written, and the idea was to join in an international effort to standardize a programming language. After that, a meeting in Zurich in June '58, which I did not attend, produced a pretty well incomprehensible document. At least Wilkes couldn't understand a word of it. In June '58, it was called Preliminary Report International Algebraic Language. For a start, they didn't know what they were talking about. Also called Algol. That's where the Algol word came in. And then there was an informal meeting with Bauer in Mainz in November '58 after that, at which Peter Landin and I were the English contingent. And that led to an Algol implementation conference in Copenhagen, February the following year, '59. And by that time, lots of people were interested, lots of compiler efforts were going on all over the world, mostly in the USA, some in Europe. And there were 40 people from 10 European countries at that meeting in Copenhagen. So that's a long answer to how did I get involved.
Fine. One of the many outstanding features of Algol 60, in my view, was the use of BNF. Have you any recollection as to how that came about?
Yes, indeed. John Backus submitted a paper to the ICIP conference in Paris '59. That was one of the occasions when John Strachey got on the table and said Algol's a lot of rubbish. It attracted wonderful attention for Algol. And to that meeting, John Backus submitted a paper with the title Syntax and Semantics of the Proposed International Algebraic Language of the Zurich ACM Game Conference. Now, he never got round to the syntax, the semantics, beg pardon, but that proposal was used by Peter Nauer to prepare a draft of Algol 60 before he ever got to the meeting. He thought, at this meeting, they're going to start with what they've got. They've got nothing at the moment. I'll give them a China egg and let it grow. Which he did, and at the meeting, in fact, Backus was saying fascinating things with the blackboard, and nobody was listening to him at all sorts of varieties of this syntax. It's lost, I'm afraid.
The main editor of the Algol 60 report was Peter Nauer. What was your involvement?
Well, strictly speaking, I was the representative of the British Computer Society. Wilkes agreed that after the event, and at the time I was nominated secretary. So I busied myself at the meeting in distributing draft text to the various participants, gathering up their comments, taking them to the IBM typist girls to type them up for further discussion, and then distributing them for the next round of discussion. Also, I proofread the final text for Peter Nauer, but I've got no recollection of those details.
Fine. One of the puzzles, I suppose, of Algol 60, especially for modern people who've never heard of it, is call by name. How did that come about?
I can't remember. What I do know, but the circumstances in which it came about are quite straightforward. Peter Nauer gathered together what papers he could to write up the conclusions of the meeting. And when he started to do this, really before we all were disappeared rather, he found there was a contradiction he couldn't cope. So he had to ask a key question, which I can't remember, and I haven't got a note of it, as to what certain text would have to mean. Part of that was that a name of a procedure occurring within the body of the procedure declaration had to represent a call of the procedure, cursive call. That was part of it. But I'm sorry, I really can't answer that. There is some text which might help someone to dig into it, which I brought with me, and that is the ACM did a big conference on early programming languages, including a very extensive discussion of Algol, with Peter Now was there, a lot of the authors were there, not myself. And in there is enough text, if you care to wade through it, to answer the question, but it's very confused.
Fine. One thing that I did, of course a lot later, was to collect test programs for Algol 60, and in that regard I followed the correspondence quite carefully of Donald Knuth. Did you have any correspondence yourself with Donald Knuth?
No, I didn't. Not on Algol 60 anyway. He was a manufacturer of organs, I don't know if you knew that.
Yes, I did actually. I organise organ recitals, one of my other functions. I mentioned Donald because one of the tests we've got is the famous one called Man or Boy, which is currently being used to test the KDF9 emulator, which we'll hear about later. Okay, back to the Algol 60. What were your views on the split of Working Group 2.1, which resulted in the parting of the ways between Algol 68 and Algol W and Pascal?
To Algol 68, yes. Well, it was inevitable, I thought, because Van Wijngaarden was ever more dominant in the discussions, and he was intransigent to a fault. He loved elaboration, and he ultimately got his own way, but not without half the committee quitting, and Dijkstra making that famous statement that what programmers need is not a more elaborate programming language, but tools for the effective construction of accurate programming. So Working Group 2.3 was born, of which I was chairman for many years. And I say that it's inevitable that the parting of the ways took place. The Wijngaarden hived off like a queen bee with a lot of bees after him. And the other side of the story was the simplification and practical considerations of those who wanted a programming language to program with and not just to pontificate about. Nicholas Wirth, in my opinion, was the predominant practitioner on that side. And he took Algol 60 and said, well, this isn't what we want. What we want is...
And that was Pascal, I assume.
Well, Algol W/Pascal. Yeah.
Okay. I must say I never got to grips with Algol 68 myself, primarily because I didn't have access to an implementation. In any case, personally, I was heavily involved in Pascal at the ISO level. And then, of course, at Ada, which you were involved in too.
Yes.
So my last question is, do you think that Ada is a worthy successor of Algol 60?
I do not. I would say that Pascal, if you want to make a nominator successor, Pascal was a worthy successor.
Thank you very much. That's a formal interview as previously arranged, as you're probably aware. If you have any other questions, please fire away. Terry Frogger.
Early on, you quoted Alan Turing about, I think it was the lecture speech you gave. You made a quote from it, did you?
Yeah.
I think the next paragraph in that same speech is the most interesting one, that the boring tasks will be done by the computer, but the computer practitioners will resist this technique by making their art as obscure as possible. It's words to that effect, and that we should fight against this. Do you think we've been successful in fighting against this trend to obscure what programming is all about?
That's a great question.
Both of you.
Well, my view is that the forces militating against a really useful, decent programming language are far too great and far too personally involved to be ever vanquished. There's finance, There's the power of corporations. I mean, the Burroughs B5000 would be brilliant, except we haven't got it for Algol.
Well, I must admit, as far as answering your question, Terry, is concerned, I did give a talk at the Advanced Programming Group about the blunders and wonders of programming languages, and that answers that question rather fully, I think. Personally, at the moment, I do quite a bit of hobby programming, and I use Ada and Python as the only two languages. And one of the good things I did was to sell my book about Perl. Well, there was another question.
Can I? Not a question, but more a statement. It's my observation that all attempts to design perfect programming languages, and define what we mean by perfect, essentially have failed. And this applies to operating systems, by the way, like Windows. And those which are ad hoc and happen just to come together in some sort of funny way tend to have been successful, mainly because those that were successful were in the right place at the right time. In which Windows is in the right place at the right time. It's ad hoc mess.
In which camp does JavaScript fit?
I've no idea, I don't know anything about it. But I've been involved with a bit of Algol 60, not much. I've observed Algol 68, which is a failure because it was tried to be perfect. The CPL, I'm afraid I'm largely to blame for, was tried to be perfect and was a failure. And so on. Whereas Pascal was one man's language. Just to put in the bits he wanted. It was simple and not perfect.
That was
Therefore, he was successful.
Yep. I was with him just after he invented it at his place in Switzerland. We saw eye to eye very well, but you see, as I say, we've got these powerful forces that we can't do anything about against the production of a really useful programming language.
I have to say on Pascal that the standardization of Pascal failed, but that's another talk.
Standardization is what David Wheeler used to call refusing to rectify your mistakes.
Jeff Hillmore, one of the criticisms of Algol 60 when it first came out was the fact that it didn't have any input-output. And this led a lot of people to say it can't be a serious programming language. Now, was the omission of input-output deliberate or something that there just wasn't time for? Or how did it come about?
It was deliberate. There didn't seem to be a common set of concepts on which one could build.
So it wasn't related to the death of the chap who was dedicated to.
Turansky? No, that was just a pure tragedy. That's why there were 13 instead of 14 of us. No, input-output was different for each computer, and well, the common, until Tony Hoare did a good theoretical job on it, you didn't have a common basis to stand with.
David Hill. Programming I do nowadays, is this working? Yes. Programming I do nowadays is almost entirely in Pascal because I have a Pascal compiler and I haven't got an Algol compiler, so that forces it. But my own opinion is that Pascal is terribly poor stuff compared with Algol 60. I'd love to have Algol 60 back. Pascal made a few small changes, not very well, positively, and so many bad steps backwards that I hate it. The one thing I like the author of Pascal for is when he was asked how his name should be pronounced. And he said, "You can call me by name as Wirt, or you can call me by value as Worth."
You could tell I haven't programmed in Pascal for donkeys.
I think we must move on.
Any more questions?
No, we must move on. Can I express that? Right, we move on. Brian Randall. I call people after an award, isn't it? According to my authored history, he worked on Algol 60 at English Electric in the 1960s. He spent 7 years researching IBM Yorktown Heights. He returned to the UK in 1971, and he actually said to me, he said, I want to join academia. So I got him a job at Newcastle, I think, I introduced him to you on the page anyway. And so since 1971, he's held a chair of computing science at Newcastle. He's been there ever since. Brown's interests range from fault-tolerant computing to the history of computing to genealogy. Few of you will be unaware that he maintains the pages relating to the county of Devon on the web portal for genealogy. Brown was elected a Fellow of the ACM in 2008. Is that accurate?
No.
No. I think it was. Over to you.
That's all of them.
I'll go send it back to him.
It was Whetstone, isn't it? Yeah. It is.
So the next one.
Brian, you'll be amused to know you can't get rid of my slides to get yours. Hit escape first.
I am doing. Marvellous. There we go. I'm exposed now. Excuse me, folks. Yeah. Oh, sorry. All back. Right. Afternoon.
You need to use the
And
mic.
I've been at Newcastle since '69. That's one of the things there.
Wikipedia's
It's a
wrong.
great pleasure to be talking in such a splendid group. I collect libraries, and, and this is a nice one. Pity I've got to waste your and my time talking here instead of exploring it properly. But I took liberties with the title. That is a more accurate title for what I'm going to talk about. So, quick summary. I was hired from college in 1957 by English Electric to work on nuclear reactor codes. That was a deferred occupation then. It was a way of not going into the army, to the benefit of both me and the army, I think. This was at their atomic power division at Weston, which was just outside Leicester. But I spent the summer with IBM in London, where they had their first computer. They had an IBM 650 there, and that was in fact very bad preparation for going to work on a Deuce. The 650 was very sleek, had nicely printed manuals, a quite simple way of programming it, etc. It was also situated behind big glass windows on 100 Wigmore Street. We had to go and operate the machine, and we were there on show. For the first 3 days of doing this, it was tremendously embarrassing. After that, you really used to like going down there and watching all the pretty girls go by. Ever since then, I've hated going to zoos. One of these is going to there. That's an old picture of the 650.
The machine's on the plinth, Brian.
Well,
On the Lex, on the,
if you
on the
point
Lex.
over there, yeah, that's what I'm trying to do. I'm trying just about every button. You want to pass it to me, and if you give the demo. Okay. Next. That's Wigmore Street. Next slide, please. People know the name Whetstone, very few people know where it is. It's in fact southwest of Leicester. Why on earth Whetstone? Next slide. Because that's where, in World War II, Frank Whittle had his jet engines factory. Next slide. That's what it looks like now. So that wasn't an ivory tower of programming. It was a place with a lot of huge, heavy engineering and the like. And that's where I went in 1957. Next slide. So, a quick summary. Deuce was based on Alan Turing's 1945 design for the Pilot Ace. As such, it was aimed very much at high speed and allowing very detailed program control. You program deuce in binary. I mean binary, I don't mean assembly language. And you exercised exact control over the timing of operations, arriving at functions, and the initiation of functions. So it was very different from, Deuce was very different from all the other machines that were around, whose ancestry traced back to the Moore School and von Neumann and co. The result of this was that in the hands of an expert programmer doing hand coding, Deuce outperformed its rivals very considerably, even factors of 4 and 5. My God, as programmers, we paid for it. I arrived there with a colleague from the same maths class at Imperial, Mike Kelly, and we were the first ones to regard the computer as fun and in fact to treat Deuce as a toy. So we wrote lots of demonstration programs when we were supposed to be writing nuclear codes, and we started thinking, why don't we try and get Deuce to help with this nasty task of programming it? It was not only difficult to program for, it was difficult to compile for. There were quite a few existing aids for programming Deuce, but they were nearly all interpreters. Interpreters could be very inefficient unless you were getting good value out of each time around the execution of the interpretation loop. You did that with the NPL matrix interpreter scheme. You did not do it with Kidsgrove's alpha code interpreter, which was just floating point scalars as opposed to fixed point large matrices. So the fact that Deuce didn't have floating point was really an important characteristic of the machine. This was a time when floating point was starting to come out. We regarded the onset of floating point as programmers, compiler writers, as not as an opportunity, but as a challenge, really. In fact, we almost thought of hardware floating point as cheating. But against that background, Mike Kelly and I developed a compromise interpreter, which was a pretty low-level interpreter, but for an interpreter was very fast. The interpreter loop, taking advantage of some very weird facilities of Deuce, was just 4 or 5 instructions. Yet nevertheless, it retained control as an interpreter. Against opposition which almost led to us being fired, we eventually produced a system called EasyCode. That was so successful that in a short time, instead of talk of us being fired, I found myself head of a small group called the Automatic Programming Section. That was the term we used to use, automatic programming. An important part of the situation there was that we were working very closely to the users of our system. So I learned very much the hard way the importance of programs and programming systems, of them being robust against data preparation, program coding, operation, and the like. I had no idea that what I learned then about the importance of, I think we may have used the word robustness then, was to stay with me for the rest of my research career. The automatic programming section was being allowed to think about KDF9, which was on the horizon. KDF9 was very different, but from Deuce, but from almost anything else as well. It had a couple of small push-down stores, one for arithmetic, one for subroutine addresses, and there was a very superficial resemblance to the Burroughs 5000. In fact, the KDF9 was a much more difficult machine to program for efficiently and to write compilers for than the B5000. Faced with this challenge, and this was at a time when IBM already had an optimizing Fortran compiler for their machines by a team led by John Backus, mentioned earlier. The Kidsgrove people, I'm sorry, I keep using the word Kidsgrove. That was where the the main part of English Electric's computer company was based. They were planning a full optimizing compiler for the KDF9, and this for the recently announced Algol 60. It was clear to us that that was not going to be available for quite a long time after KDF9 was available, and that people were going to need to be programming the KDF9 from the start. So we decided that we would try and produce a system, starting against that background with EasyCode, where we were emphasizing programmability and ease of use and speed of availability, so to speak. At about that time, there was an organization called the Automatic Programming Information Center, run out of Brighton College of Technology. That produced a number of books, but also organized a conference. And it was a conference at which Dijkstra spoke and gave a talk, perhaps one of his very first talks, on his compiler. The Kids Grove team and I and my team, that's an exaggeration, I and Lawford Russell, who by this time had replaced Mike Kelly, who went off to microprogram the IBM 36040. Lawford and I and the Kids Grove team were in the audience, and we were entranced by Edsger's description of his compiler. And it was somebody from Kids Grove who said to me, why don't you, for your work at Western, try and base it on Dijkstra's work, if he would be willing to give you the sort of information you'll need. We were in severe danger of inventing our own programming language at that time. This very good piece of advice, we eventually followed up. It took a long time to persuade English Electric that they could afford to send us to Amsterdam. Foreign travel was very exotic in those days. So, next slide. Catching up on what I've been saying, that's the pilot ace which eventually came out of the work done by Alan Turing. Next. That's a picture of Juice. I spent many hours in front of a desk like that. What you can see on the right of the desk there is the little card punch, which we use to punch binary cards. Next slide. And that is a copy of the report on our EasyCode programming language. I find it very embarrassing even to find a report of mine which says at the bottom, supplied by the National Archive for the History of Computing. That is not good for the morale. Next slide, please. So, that summarizes the comments that I've just made. Next slide. I was hunting on the web. I couldn't find anything much about APIC, but I knew that it was at Brighton. That's a picture of Brighton College of Technology, allegedly. Next slide. You can see Van Wijngaarden in the middle of that picture. The one with a sort of receding hair and then a lock of black hair. That's Van Wijngaarden. And the X one at the Mathematical Centre, the Mathematics Centrum in Amsterdam. Next, please. And that is a picture of the Mathematical Centre. I believe at that time, though I cannot claim that I can really remember that it looked like that.
It was in a brewery.
Sorry?
It was in a brewery, wasn't it?
That sounded likely. You know,
it was in a brewery.
That fits with that. Okay. So, Lawford and I managed to spend a wonderful week in Amsterdam, a week which changed my career. And certainly, I owe a tremendous amount to Dijkstra, and in particular to that week. What we did in our discussions with Dijkstra was in part learn about his X1 compiler, but also the three of us essentially start planning the design of a new translator interpreter system. I could easily spend half an hour talking about that week, and I won't. What I will say is that when we got back to Western, we then wrote a quite detailed report entitled Discussions at Mathematical Centre. We sent that off to Dijkstra, And we learned a little while later that he was then distributing that to people. The people who wrote to him asking about his compiler, and typically the people who wrote to him asking, can we come and see you please? So quite unintentionally, we found we had put that sort of roadblock in the way of other people gaining the direct benefit that we had. So, I had lost my copy of that report. Again, I could spend half an hour telling you how I eventually found it, but that's somewhat irrelevant. The X1 was, I believe, the world's first Algol compiler. Certainly the first to cope with all of the major new challenges after what was belatedly called Algol 58. Indeed, I remember a number of the Germans campaigning to try and get those things that they thought Peter Nauer had sneaked into Algol removed from the language because they didn't know how to compile it. When Dijkstra then showed how to compile it, and those objections didn't seem to have much strength. There was very little at that time on how to write compilers. I remember just one book on, not one I particularly liked, on Neliac, which was a sort of dialect of Algol 58. There were quite a few papers on syntax analysis and that aspect of compiler writing. But basically, I would say that we very much pyramided our work on Dijkstra and our detailed discussions with Dijkstra on what should happen now following from his experiences with his compiler. Next slide, please. Oh, I've always remembered that Mathematical Centre had a policy for putting up their visitors in Hotel Krasnopolski on the basis that no matter how drunk you were and how foreign you were, any taxi driver would still work out where you were trying to get to. Next slide. That's a picture roughly contemporaneous, I believe. That's the report that I managed to find. That report is now on the web, by the way. Next, please. So, we were back at Whetstone. We were waiting for the KDF-9. One particular aspect of Dijkstra's compiler we were not satisfied with was the way in which, and this fitted with his character, when it found a first error in somebody's program, it stopped. And so you had to get the program through the compiler, one error at a time. We dreamt up a scheme that we were, and I think I'd say I still am, really quite proud of, which went on through the program and had a very good chance indeed of correctly reporting a large number of errors in the program and avoiding producing lots of erroneous error reports. And it did that in a comparatively simple way, not by any scheme of trying to analyse the possible causes of any error. We wrote that up as a report. We sent that to Edgar. The letter that came back quite quickly was the first letter I had from him, which addressed me as Dear Brian. Always before that, it'd been Dear Mr. Randall. I felt I'd just been awarded an MSc. And I really felt that way. That was an important thing. He may not have meant it that way, but that's how I took it. We chose to invent, next slide please. Next. That's how KDF-9 was supposed to be. That's an installation which I never saw. That amount of space, that amount of equipment. Next please. We invented flow diagrams, a style of flow diagram, based on the sort of documentation that was used in writing machine code programs for Deuce. We produced of the order of 130, 140 such flow diagrams, which we then coded in the rather limited KDF-9 assembly language called user code. There were other ways of writing compilers. One thought was, would it be possible to write the compiler in Algol itself? the notion of bootstrapping was something that we certainly didn't feel confident that we understood it enough. This set of flow diagrams were pretty well complete, but KDF9's delivery date started slipping incrementally and repeatedly. These delays were very disruptive, but the disruption we put to very good use. First of all, a number of colleagues with other machines took our diagrams and started implementing our compiler. The Western compiler was not the first Western compiler, if you see what I mean. Somebody, I think it may have been Mike, I'm not sure, said, why don't you write a book on your compiler? We thought that was a very strange idea. We asked a number of people, including Dijkstra, and we got some positive responses and some excellent advice from Dijkstra, which was along the lines of, a simple, detailed description of your compiler will be of very limited interest to a very few people. But if you write a description of the design in which you document every design decision that you took, and for each of those decisions, all of the alternatives you considered, why you took the one that you took, and now what you think of that decision, that would be an interesting book. A whole generation of PhD students at Newcastle have had that advice from me. And it's done my thesis a lot of good. That was bloody good advice. The KDF9 was still being delayed. We believed that there was a race on to produce a book on Algol compilers. We thought that Peter Naar in Copenhagen and Gerrit van der Meij in the Netherlands were both writing books on their compilers. So Lawford and I worked incredibly intensively, mainly in our spare time. I took 2 weeks off to get married in the middle of this, but that was it. And in 9 months we produced the book. We were totally naive. We sent academic press a manuscript which was far neater and far more complete than I think any they'd ever seen before. Certainly any that I've ever seen anybody give to a publisher. Dijkstra warned us of all the bad experiences he'd had in typesetting of mathematics and Algol and the like, and urged us to use photo reproduction. We ignored the advice, but instead we had 4 typewriters altered, so that they had the strange Algol characters, like for example the little pen, and also, and I'm still proud of this idea, the digits were italic and the letters were non-italic. So there was no confusion at all between 0 and O, and between 1 and L. And so that worked very well. KDF9 was still being delayed, and somebody, or perhaps we, were told that, oh, there's another 2-week delay, but that's just it. So we had the idea of, can we write a little, some sort of little compiler for Deuce itself now, ignoring all of our detailed design for a full compiler. And so we wrote a compiler for a little language which allowed you just 26 variables, A to Z, which matched the first 26 words in a delay line. There were a succession of further 2-week delays, by the end of which we had a system which had procedures and for statements and input-output, and which people were starting to use, damn it. But then at last the KDF9 was allegedly available, and we started using it. Whenever we had trouble with the machine, we would run our compiler on an emulator for the KDF9 written on Deuce. If the results of the real and the emulated machine did not match, we just handed both back to their respective designers and said sort it out. And only when there was an agreement between the two as to what the answer should be did we carry on working on KDF9. I should explain that we were in the brilliant position of not really being a customer and not really being a producer of the KDF9. And we took shameless advantage of that situation in all sorts of situations. So, Our machine, our compiler was meant to work on a minimum configuration KDF9. 8K word to memory, tape unit, no drum, paper tape input and output. It was meant for program preparation. Lawford Russell did a brilliant job on making sure that the compiler ran in a single pass while the tape was running. It kept the paper tape running at full speed. When the tape ended, there was a completely invisible period of delay. Essentially, the compiled program started running through the interpreter immediately. You could use Whetstone Algol at no cost. The contrast to Kid Strove's assembly routine was wonderfully embarrassing because that seemed to do most of its assembly after it had completed running, reading the program. The other compiler that we were very aware of, not in great detail, was Tony Hoare's Elliott Algol compiler. That was certainly, I believe, ready before any of the ones completed on, built on our design. He then published his famous algorithm for quicksort, but his publication for quicksort included something along the lines of, I'm given the description recursively, but of course it is necessary to provide a non-recursive explanation of this. And that was what he certified using his compiler, because it didn't handle recursive procedures. We very mischievously certified it quicksort as soon as our compiler was working, and that was, in a certain sense, the first public announcement of the Whetstone compiler. I alluded to Gerard van der Meij earlier, alongside Peter Nauer, as another compiler. I think that's probably the most impressive Algol compiler ever, perhaps the most impressive compiler ever. It was a more complete Algol 60 compiler than any other I ever heard of. It was written entirely by Gerard van der Meij himself. He had assistance from some colleagues in debugging it. The background to this, for those of you who don't know, is that he was completely blind and completely deaf. And he had been since the age of 18. Quite mind-blowing. Fraser Duncan of English Lecture Kidsgrove took me to see him once in the Netherlands. And it was a humbling and a wonderful afternoon that I spent with him. The one other Algol compiler worth mentioning that we were quite aware of then was one by Brian Higman for an incredibly small GEC machine. Looking at my notes, it was just 512 20-bit words. God knows how it worked. But elsewhere in the UK, most of the action seemed to be to do with autocode, and that was something that we didn't pay very much attention to. By 1964, the Whetstone system was, those two flow diagrams. The first, the one on the left there, is the complete flow diagram for our scheme for going on and finding multiple errors. I'm not suggesting that you could read it from now, but just giving you there to give you an impression of the level of detail in our design. And the thing on the right there is the update display routine. Recursion, blocks, block structure, the display were all incredibly new and foreign to everybody at that time. The people who were working on our flow diagrams while we were waiting for KDF9 were also reading drafts of our book. The chapter on blocks and displays was rewritten 5 times. It ended up by being by far the simplest part of the book, but it started by being far the most obscure. And that is the actual flow diagram for update display. That really was, so to speak, a pinnacle of compiler writers' art, so to speak. Well, not compiler writers, shall I say, machine architecture, block structured machine architecture at the time. So, By 64, the Western system was operational. Incidentally, as far as I can recall, we never called it Algol. It was other people who insisted doing that. More compiler projects had been based on our book. I'd been headhunted by IBM to join the IBM Research Center in the States. And I had agreed on condition that I wasn't involved in any compilers, certainly not any Algol compilers. I wanted to do something different. They agreed to that quite readily. But I also asked whether it would be possible for me to join the IFIP Algol committee. I had been invited onto that sometime earlier. There had been just no possibility of getting English lecture at Whetstone to fund my attending foreign meetings. So I attended in 1964 the meeting of the Algol committee, which coincided with the conference in Vienna on formal language description languages, when two worlds came together and collided. The world of formalists who were interested in syntax and people who were interested in programming languages and compilers and the like. And I still remember, I think it was somebody like Cal Algott with his arm around Nat Rochester, walking down the corridor saying, effectively, there's them and there's us. It really was, in some sense, a very bad-tempered conference with a wonderful after-dinner drunken speech by Fraser Duncan at the end. So, over the next few years, I found myself in the midst of the growing controversy, which eventually culminated in Algol 68, and I was one of the 7 who wrote the minority report. I, in fact, was the one who, I was told afterwards, read out the report, rather like a Scottish Presbyterian minister. The final anecdote. The people who wrote the minority report resigned en masse from the committee then, and then a number of us set up the Committee on Programming Methodology, whose other parent was the NATO software engineering conferences. It wasn't straight out of Algol, it was out of Algol plus NATO.
And those were your words, programming methodology.
I'm not sure that I want the best of English, but still. Final anecdote after, because certainly the minority report and all that is another story. When I returned to the UK in 1969 to the chair at Newcastle, I found that Whetstone Algol was still being used there for the entirety of their first year programming courses. Quite large numbers of students running on a now rather aging KDF9. I immediately said, I hope you don't want me to help solve any problems with that. And the immediate answer was, we wouldn't let you touch it if you asked. I can also claim no credit at all for the recent splendid efforts by David Holdsworth and his colleagues, who have succeeded in getting Whetstone Algol translator and system working again, starting just from a line printer listing that had to be repunched and running on an emulator for the KDF9. I have just been an admiring spectator, and somebody who almost invariably, when asked a question about what does this mean or how did that work, I have to say, I have no idea.
We'll take questions when we get to the very end, I think, because they never do this over time. You always learn something new at these things. I learned that it was good that I went to see Dijkstra for 2 weeks, actually, not 1 week, before you went. Otherwise, I'd never have got in. I was a research student, not what I want to do. I was not actually employed to do anything. Thank you very much, Brian. Now we sort of go into a slightly different part of the programme, where 2 distinguished speakers in themselves are actually going to give speeches given by others who aren't here. They're going to read their thing. We've got 2 people, Cliff Jones. Cliff has worked with Leo, Esso, Ford, IBM, Hursley and Vienna, Manchester University, and from 1999 he's been in Newcastle. He involved with interdisciplinary research collaboration on dependability of computer-based systems. In IBM, some time ago, of course, he acted as the liaison between the the PL1 compiler writers at Hursley, and the PL1 formal definition group in Vienna. Cliff is a prominent advocate of formal methods, with the rare advantages of having done some real programming experience. Richard Bornat was at Queen Mary College in the 1970s, which Peter Landing had joined previously. In the 1980s, he wrote the highly regarded book, Understanding and Writing Compilers, a Do-It-Yourself Guide. He moved to Middlesex University in the 90s. He's now retired. He kept in touch with Peter Landing until Peter's death last year and wrote the obituary that subsequently appears in The Guardian. So, Cliff first.
My slides, into the 60s.
So I find myself in the unusual role of reading out somebody else's contribution. First of all, Tony Hawes. It's a great honour to read something that Tony's written, but this is not my conventional mode of delivery. I don't even promise to do it terribly well. Which button?
That's forward, that's backwards.
Right. So, Tony's essay. Has everybody got a copy, by the way? Are they going to be made available afterwards?
Yes,
I presume so, that's no problem.
I asked partly because there's a footnote which is...
It will certainly be in Resurrection.
Right, okay. There's a footnote which is not terribly easy to read out. Tony wasn't very kind about this. I think Jeff's responsible for this. The word security is used in what's going to come along in a slightly unconventional sense. If you really want, I'll read the footnote out at the end, but it's not the normal meaning of security. So Tony's contribution reads, in quotes, "Here is a language, Algol 60, so far ahead of its time that it was not only an improvement on its predecessors, but also on nearly all of its successors. Of particular interest are its introduction of all the main program structuring concepts and the simplicity and clarity of its description, rarely equalled and never surpassed." Unquotes. This is a self-quotation from Tony. The quotation is from the appendix of the published version of a keynote I gave at the ACM SIGPlan Programming Conference, October 73. The talk put forward the view that the primary purpose of a programming language is to help the programmer in the practice of his art. It should give him the greatest assistance in the most difficult aspects of his art, namely program design, documentation, and debugging. The relevant criteria I gave for judging the quality of a language included simplicity, security, and readability. Unquote. Most of my talk described how several of Algol 60's rivals and successor languages pursued alternative criteria. Quotes, "I do not wish to deny that there are many other desirable properties of a programming language. For example, machine independence, stability of specification, use of familiar notations, a large and useful library, existing popularity, or sponsorship by a rich and powerful organisation." Yes, I think we know who the dig is there, or several digs, unquote. Subsequent history has shown that these desirable properties have been dominant in the choice of programming language by the vast majority of programmers. It was the failure of the Algol family of languages to meet these criteria that contributed to their eclipse. Direct answer to a question earlier. Even so, the ideas and the ideals of the Algol family of languages live on. They are most apparent in newer language designs such as Java and C#, and in the continuing stream of features that are being added to those languages. Even beyond just programming language design, the Algol influence stretches to the design of application programmer interfaces for general purpose and special purpose library packages. It extends also to design patterns which are widely copied with adaptation into programs written in existing languages. A design pattern is an embodiment of software architecture or an implementation of an abstract programming concept. Effectively, the user of a design pattern is coding by hand a new structure or feature of a more abstract design language. I particularly like that point. There remains the objection that the extensions to existing languages only build further complex superstructure on foundations that are already too complicated and inherently insecure. Closing paragraph, I think very good call. So let us not abandon research to discover a language which combines the simplicity and security of Algol 60 with the full range of modern program structuring principles used in libraries and design patterns. These include resource management, control of responsiveness, object orientation, distribution and concurrency. Such a language would play the same fundamental and unifying role in computer science as the framework of natural law plays in other branches of science. Even if the language never achieves wide usage, everyone who understands and appreciates it would thereafter be a better programmer, no matter what language they used for coding their designs. Because that, in essence, has been the real and enduring contribution of Algol 60. Tony's original hints on programming language design wasn't available at the conference in '73, but is online available as a Stanford report. And there's a book, Essays in Computing, which collects a lot of Tony's contributions, many of which are of course about programming language design. It's a very odd book. It sold almost 0 copies when it first came out as the 50th book in the Red and White series. ACM recently held, or a couple of years ago, held a poll of the most wanted out-of-print books. And this comes high on the list. Why people didn't buy it, I don't know. But the effect is that it's now freely available online at the ACM portal. You can copy out the whole address. You can just go to the ACM portal and search. So you can get the whole book in downloadable form now. If I might just make a mention back to Brian's reference to the Baden by Wien conference, the Vienna conference. Tony's work was heavily influenced by that conference, and I think Steele's book, which collects the papers and the discussion from that conference, also all be on this list of most desired out-of-print books. Thank you.
Right. Richard Bornat is going to tell us about Peter Landry. It's a simple way to put it.
Yes. Right. Do something of that sort. Full screen. Full screen. Bottom off. No, view full screen. Slideshow.
There you are. I didn't review.
Okay, so. There we go. Okay, this horrible black bar appears. My connection with Algol 60 is that the first proper programming job I wrote an Algol 60 compiler at Manchester Regional Computer Centre. And, I left because they wouldn't let me write an Algol 68 compiler, for which I'm eternally grateful. My academic career is due to that decision. Okay, I feel very inadequate standing here in front of many of the legends of my boyhood and youth, I'm fairly sure that Peter Landing wouldn't like anyone doing this job, and I'm absolutely certain he wouldn't like me doing this job. I was a colleague of his for 24 years, and I understand his work somewhat, but I'm not sure I understand it well enough to be really talking about it here, and I wish that John Reynolds and Rob Burston was doing this instead. So, okay. Do you know a paper where they ask you to put in keywords and you never know what to say? And you put in all sorts of concurrency or something. This is what Peter Landing put in. Explaining to programmers the logical structure of programming languages is like a cat explaining to a fish what it feels like to be wet. Quite a sore gall. Unfortunately, of course, I'm a fish. Okay, he was friends with some cats, including Peter Landing for some time. Okay. So Landing's essential contribution was in recognising that programs are mathematical functions. And we fish would say, I like mathematical functions, but for the purposes of this talk, programs are mathematical functions. Okay. And the calculus of mathematical functions existed. wasn't very well known, certainly amongst programmers, and his contribution to computer science was to show how we could define the meanings of programs and programming languages using the lambda calculus. And that really is it, but that is a fantastic contribution, amazingly fundamental to everything that followed on. There's a great deal of technical detail as well, which I won't have time very much to talk about. Okay. I once tried to sack Peter for not being productive enough. George Coulouris said to me, in polite George Coulouris way, your contribution to computer science will never be as great as Peter's, no matter how long you live, and I had to acknowledge that that was true. I gave up, and Peter forgave me, which was wonderful. This is all that he wrote, this is all that he published. The mechanical evaluation of expressions, his papers, after he died, Rod Burstle and Olivier Danby have retrieved them, and they're going to be in the Bodleian Library. They may already be in the Bodleian Library, near to Strachey's papers. So the work that he did before 1964, in particular his input to Algol 60, will be in those papers somewhere, but was never published, and I haven't had any access to it. And since Peter didn't talk about those days, I don't really know much about it, so I'd love to hear if anybody does know. But the mechanical evaluation of expressions is in a real sense his reaction to the problems of defining the semantics of Algol 60, because not only did Bacchus not get around to defining the semantics of Algol, the Algol report didn't really get around to defining the semantics of Algol, although there were some English and misinterpretable words. I know as a misinterpreter. Which were included. So the mechanical evaluation of expression was his first attempt. He worked for Strachey as a research assistant, and took a great deal of his worldview, of his view of computing from Strachey, and Strachey took a great deal from him. Programs as functions in the lambda calculus, that was Peter, and he gave that to Christopher. So the mechanical evaluation of expressions says, here is a way of interpreting lambda calculus expressions as programs. And look, here's a correspondence between those lambda calculus expressions and a programming language which you know, which is Algol, or is Algol-like. He was never, at that point he wasn't really trying to talk about Algol. And there are things missed out because I can't do them yet, particularly jumps and assignments. So the mechanical evaluation of expressions set out his program for trying to explain programming languages in terms of the lambda calculus. So procedures were obviously lambda formulas. Blocks also were lambda formulas applied to values which were the values of the initializing expressions. He was headhunted and his wife was brain drained in the early 60s to the US to work for Univac. And I'm not sure that he actually did anything very much while he was at Univac. He had a good time in New York. The stuff he wrote actually was summaries of and reworkings of the times that he did with Strachey. So whilst he was at Univac, he published a generalization of jumps and labels, which introduced the J operator, and a way of talking about, in particular, about what he regarded as necessary in programming languages, was a way of talking about failure exits from procedures. When you apply a procedure and the arguments don't fit, what do? Well, you have to do something like jumping out of the procedure to some other place. So essentially exceptions. And that's the one which has the quote from Sir in the front. The same year, he published a much longer version in two parts in the ACM Communications, the correspondence between Algol 60 and Church's lambda notation. And he described, he took the mechanical evaluation expressions and introduced the SECD machine. And the correspondence between Algol 60 and Church's lambda notation, he elaborated the lambda machine, the SECD machine a little bit to deal with addresses in a very complicated way that he described as sharing. And I think, quite honestly, it's so obscure that you sort of have to know what Strachey did with R values and L values a couple of years later to realise what he was talking about. It's not done formally. There is, however, an incredibly formal, part 2 is an incredibly formal correspondence between all parts of Algol and essentially his modified lambda notation, modified only so that it has jumps and labels in it. The J operator and assignment and assignment operations. The same year he wrote an abstract machine for designers of computing languages. One of his programs, published in a conference, part of his program was to try to say that the SECD machine could be the basis of the design of computers. So for him, Algol 60 was the stimulus for saying the lambda calculus can be interpreted, and look, the interpreter could be what you build in hardware. So that future computers, he thought, would implement the SECD machine. It obviously never happened, or even nearly never happened. But that was his aim. And then in 1966, he published what was his manifesto, the next 700 programming languages. Interestingly enough, 700 is a typographical mistake. As many of you will know, the lambda calculus wasn't originally a lambda calculus. It was going to be X with a little hat over it, and a typist couldn't put the hat over the X, so she put it in the front. I presume it was a she. And then a typesetter thought that it was a slightly misprinted lambda, put a lambda in. That's how the lambda came about. 700 was because Peter had a rather extravagant way of writing a 1 in the French style, you know, when you see it on Apple stores with very big long serif and tiny little tail. So he wrote that sort of thing, being a rather sort of flamboyant person. And the typesetter thought it was 700 and he put 700, and he thought it was a better joke than 100. So he's been saying it ever since. He was one for jokes, he was one for flippancy, and oh yes, I haven't got the one I missed out actually. He was one for flippancy. He called the language, which he defines in the next 700 programming languages, or rather the family of languages which he defines in the next 700 programming languages, ISWIM, if you see what I mean. And that's a joke, but it was the first language with a complete formally defined semantics. In the correspondence between Algol 60 and lambda calculus, he tried with Algol, but there were so many weird little corners of Algol, including, in particular, he had trouble with own. When I wrote my own Algol compiler, I didn't do own because by 1968 it was completely clear that nobody knew what it ought to mean. And Peter also bothered with jumps into conditionals, which you could do in Algol, and uninitialized blocks, uninitialized variables, which messed up his semantics quite a bit. So ISWIM doesn't have any of that. But actually, this paper too was published with conference discussion afterwards, and the conference discussion starts out. The first page is all about whether the offside rule, which introduced in the 700 programming language, if you don't know the offside rule, it's that if you can use indentation rather than brackets. But everything has to be, I have to do it my way around and then turn it around for you. Everything has to be southwest of the first character of the phrase which starts it off. So you write a line, and then underneath you can indent stuff, and that's included in the
Southeast.
Yeah. Southeast. I was getting east and west. I always get east and west. Thank you very much. Yes. Okay. There is another. Yes, the formal description of Algol 60 is the same, essentially the same material as the correspondence between Algol 60 and lambda notation, presented in the same year, presented at that conference, which is reported in formal language description languages. And in my first proper job as a programmer at the National Computer Centre, it was the only book in the library that wasn't about numerical analysis. And I could only read the conference discussions. I couldn't understand any of the technical stuff. Gave off an atmosphere of tetchy incomprehension, which I've noticed has been carried forward in every programming conference I've ever been to in my life. So they obviously set some sort of style. Okay, and but the next 700 programming languages actually is more a celebration of Lisp than of Algol. only makes remarks about Algol 60's failure to define itself properly, and some slightly dismissive remarks about the reference language, publication language, hardware language distinction. Most of it is a celebration of Lisp. He regards Lisp as more or less right, and he says so. He was inspired mostly by Lisp, or rather by what Lisp could have been, because of course when he invented closures in his in the mechanical evaluation of expressions and in the Algol 60 paper, and when he tried to sell it to the people in MIT, when he worked for MIT, they wouldn't believe him. And they carried on with what they called, was it called static binding? The mechanism of Lisp 1.5, which was not a proper treatment of environments in functional values, and they got it wrong for a decade and a half until Sussman finally woke up and implemented scheme. Then he came back to England and did more or less from so far as Algol 60 types and programmers like me are concerned disappeared. He wrote a couple of algebraic papers, one with Rod Burson, one on his own. And then drifted off to be a gay activist. He did want in the 70s and in the 80s to do the same job on Java that he'd done on Algol 60, but he never could. So objects and the correspondence between object-oriented objects and the lambda calculus, he never could sort out. It's interesting that in the next 700 programming languages, in a formal description of Algol 60 and in the correspondence between Algol 60 and Church's lambda notation, it's quite interesting that a great deal of effort is spent on dealing with the syntax of Algol 60, dealing with forms. This form is like that form. How do you say what this form is? And surprisingly little space. The SECD machine is dealt with in the SECD machine, which is after all one of his great contributions, is dealt with in detail in the mechanical evaluation expressions. And his modifications to it are only vaguely gestured at in the formal description of Algol 60 and the correspondence between Algol 60 and Church. And he didn't publish again after 69 until he wrote some papers in his declining years talking about, because people were getting interested in his work again. Olivier Danvy has published a few papers in the last few years which say how Peter's work corresponds to later work, how the SECD machine corresponds to continuations and so on. So that's his trajectory. Mechanical evaluation expressions introduced the notion of syntactic sugar, which showed how to translate Algol into lambda calculus, didn't do assignment and jumps. Later on he did stuff with jumps and assignment, but struggled with own and who wouldn't. The next 700 programming languages was his manifesto, and the point, I forgot to say it, the point of the manifesto was to say functional programming is the thing. He and Strachey in the discussion afterwards banged on and on after the discussion of the offside rule about functional programming. This was the way we ought to be using equivalences. And interestingly enough, Van Wijngaarden in the Formal Language Description Languages Conference mounted a defence of non-functional programming in terms of the distinction between constructivist and Platonist logic, which I hadn't seen until I researched this talk. And then he stopped, rested, that was it. So Lisp was his inspiration, not Algol. So the most important contribution of Lisp was in the logical properties lying behind the notation. Essentially, substitution of equals for equals. This expression and that expression will go for each other. Lisp simplified the equivalence relation to determine the extent by which pieces of program can interchange. Lisp brought the class of entities that are denoted by expressions of program can write nearer to those that arise in models of physical systems than in mathematical and logical systems. That was his manifesto. Icewind was an improved Lisp, using Algol-like syntax. But along the way, he showed us closures which Sorry. Okay. He wrote this sentence which I think I understand. To be is to be the value of a variable, Quine's dictum. Out of that grew Strachey's first-class citizens. He was, those of you who heard him talking in the symposium here on oh gosh, what was it on? Oh, the early development of reasoning about programs will know how self-deprecating he was towards the end of his life. So, out of his understanding of Quine's dictum, grew his notion, which is in the 700 programming languages, that things should stand for values in programs, and out of that grew Strachey's first-class citizens. That's how it happened. And he was, as I say again, he and Strachey either invented or were the early, very great proselytizers for functional programming. And were detailed proposals in the next 700 programming languages for how to do multiple argument functions using lists and single argument functions and things. And so he missed various tricks, but so he helped to define our subject, and even though the fish never quite swallowed the lemon.
Both Peter and Strachey. There's no doubt in my mind that Strachey gathers a lot from Peter. I think a lot of Strachey proselytizes an awful lot more. Peter really was provided the basis for it. You know, remark on that. Okay, we now have to Jones again to talk about Luca, a contribution from Luca Cardelli.
Sorry, Kevin, I should have hit escape.
Can I just ask a quick point of clarification?
Yeah.
You said Landon was looking at trying to do the same for Java in the 1980s.
Yes.
You can't admit that because Java's 90s. Do you mean 90s or do you mean a different language?
I mean 90s. Time slips by, so.
So this time I'm going to pretend to be Luca Cardelli, but just before I do that, could I just pick up on something that Richard said? Peter did speak at the first of two attempts to talk about theory here in this room, and fortunately it was captured on video. The first conference had distinguished people like Tony speaking in the flesh, not through me. Unfortunately, the sound of Tony's contribution was lost, but Peter's contribution is there completely. I have a copy of that on my laptop, so it does exist in machine-readable form, the video with the speech. And it's a fascinating contribution, as Richard said, completely underplays his own role in the subject. The other thing I'd like to say on my own behalf before I go on to Luca's talk is the incredible impact that Algol 60 has had on formalism, formal semantics and so on. It's probably the most defined programming language. I've certainly written a couple of definitions of Algol 60 in various notations. Many other people have it. It's a sort of test bed. If you can't define Algol 60, then you shouldn't be doing it. And objects are really not that difficult, Richard. Right, Luca Cardelli's contribution has a title, Tony's actually didn't, and it's very telling. It's an Algol 60 spiritual user. I'll give you a bit of a clue about what's coming. Luca essentially tells you that he didn't really write Algol 60 programs, but at the end comes back to the value of Algol 60 in our thinking. So bear with it. Mike even bear with it when he praises Algol 68. So I will now read. Algol 60 was one of the most talked about programming languages when I was an undergraduate in Pisa in the early 70s, and it clearly had a great influence on my studies. I should, however, make it clear right away that a language with a grand total of 3 types, real, integer, Boolean, had no conceivable practical use for me. The avant-garde languages of the time were Simula 67 and Algol 68. I carefully read the grid-arranged chapters of the Algol 68 book in both orders, and the object-ridden Simula 67 book a few times. Although more attracted to Algol 68, I ended up using Simula 67 as my main programming language because it was available on the IBM mainframe. Considering the alternatives, Fortran, COBOL, PL1, Lisp 1.5, there was really little choice. Simula 67 had Algol 60 as a subset, but I was attracted to it mostly by its rich type system, garbage collection, string processing, none of which were features of Algol 60. Algol block structures were put to new uses as objects. I think that's a very important observation. Were put to new uses as objects, inventing object programming, object-oriented programming, over 10 years before it became widely popular. There is no doubt that through Simula I was raised in the algorithmic programming style of Algol 60 and on the structured programming approach of Dijkstra and Hoare, to the point that later in my life I could never bring myself to read assembly language programs, i.e. Knuths. That must surely count as a negative influence of Algol 60. The other main influence on my education was lambda calculus, and through it Lisp 1.5. I used Lisp extensively, but I never enjoyed it because compared to Simula, it had no types and its supposedly advanced interactive environment was actually quite bizarre. The main connection between lambda calculus and Algol 60 goes through Landin. I was familiar with that work too as an undergraduate. Algol 60 also deeply influenced my studies on denotational semantics because some of its more challenging applications were in the semantics of imperative languages, typically Algol-like, through Wadsworth's continuations. After my graduation from Pisa, the influence of Algol 60 on me stopped for a while. I moved to Edinburgh and started studying various schools of formal semantics and functional programming. I found the compilation of functional programming languages to be an interesting topic and decided to implement an ML compiler. But implement in what language? Surely not in error-prone Lisp. And ML itself was not up to the task yet. I no longer had access to Simula 67, but we had Pascal on the department's VAX. Hence, Pascal became the most Algol-like language I ever actually used. It had no objects, no garbage collection, but was perfect for systems programming tasks of the time, including implementing a compiler. A bit later, my first paper on ML type checking was published with an appendix consisting of a modular 2 version of my Pascal code for the Hindley-Milner algorithm. That was because Algol still had such a large influence that reviewers rejected the obscure ML code that I had first written for that appendix. The purpose of the discussion so far is to set the context of my involvement in Modular 3, because this is the only possibly Algol-like language that I helped design. Functional programming, the main subject of my research, was not up to the task of writing real systems programs. During my first job at Bell Labs in the original Unix group, I used C extensively. By the time I moved to Digital Equipment Corporation, I was glad to return to a more Algol-like language. Modular 2 Plus was a Xerox PARC-inspired extension of Modular 2 that was widely used at DEC Systems Research Centre. It had a strong list of innovations, but was in need of a redesign. The general problem to be solved then and now was to carry out systems programming in a well-structured and type-safe language. My main contributions to Modular 3 were in reformulating the type system of Modular 2 Plus, using techniques coming largely from functional programming. An explicit goal of the Modular 3 committee as a whole was to be inspired by both Simula 67 and Algol 68, and of course Modular 2. For about 10 years between Simula 67 and Java, Modular 3 became my favourite programming language and my favourite working language of all time. I still regard its module structure as unsurpassed, and I say this as a user rather than a designer. It made it possible to cleanly structure the large programs I was writing in ways that I have not found in other languages, including modern or functional programming languages. Which brings us back to Algol 60. The original spirit of Algol 60 was the effort to structure algorithms so that they can be better understood, in contrast, for example, to structuring functions or equations or formulas or machine architectures. That is what has always driven me as a language user and designer. Algol 60 did not have much of a type system, but its direct successors, Algol 68 and Simula 67, made radical and divergent contribution to structuring algorithms by types. It did not have Simula's, so Algol 60, it did not have Simula's classes nor modules, but both have evolved from program blocks as independent disciplines of programming. Algol 60 lacked all the most important features, and yet its spirit inspired them all. Algol 60 is my favourite language that I have never used except in spirit.
You get the prize for the first one being under time. Thank you very much. We come now to what's really is the fourth quarter of a four-part opera, where we're going to hear about some more modern activities in reviving some of these old compilers. First of all, we've got David Holdsworth, who, I probably got this all wrong as well, put my glasses on. Many years he was a senior member of staff of the Leeds University Computing Service. He was much involved with other systems, such as the KDF-9, the ICL 1906, yes, and Amdahl systems. There's little he didn't know about their operating systems and language compilers. He's now the leader of the CCS Software Conservation Project, spent much of his time developing emulators of historic systems and obtaining the codes of operating systems and compilers and coaching them to work again. He's going to tell us about some of his recent coaching.
Thank you, David H. I called my PowerPoint David H. first in the first draft until I realised it was not a unique identifier. Thank you.
Let me just go through. Or I sit there. Let's get rid of that because that's redundant.
When we get to the fancy bit, I might have to call it. Those of you who never used KDF-9, Algol, might not recognise that, but it's actually the cover of the KDF-9 Algol User's Manual with my title superimposed upon it. Algol, I think it was called Algol because kids drove Algol got called Calgol. And it's divided into three parts, like Caesar's goal. The translator, which converts the Algol to pseudocode that Brian talked about. An assembler for code procedures, because of course Algol ducked out of the I.O. by saying, well, you could write those in any old programming language. And then a controller for the runtime system. We only have parts 1 and 3. Part 2 appeared much, much later in the life of Western Algol, and in fact was produced as a kind of mix-up between myself and Chris Phelps at Oxford to start with, and then appeared as part of Post System. Now, if all the technology works, I felt we should try to show Don Knuth's program running. That's the GPS test. Now, if the world is kind to us, you should see some output there. And that was generated. Bang! Notice there is work remaining to be done. That's not quite right, but we're not far out, you know. But that is Western Algol rerunning. A while ago I ran Hello World, and Brian Randall countered by saying it was the first time Western Algol had run Hello World, because it wasn't fashionable at the time when Western Algol was actually happening. Now, Algol is a child of the 1960s, because it predates YAC. It's an operator precedence parser, and so its error messages now look rather unfamiliar. It also predates interactive editors, and so the error pinpointing is designed for use with line printer listings or FlexWriter output. Now, I have here produced, where's the page down key? There will be a way of doing a page down.
Use 2 fingers on the
pad. Here's, those of you who knew KDF9, this is what a FlexWriter output looks like. This is cheated, but with HTML. But that's what it looked like. And of course, what would happen is you'd edit the paper tape, and you get a printout off the FlexWriter for the bit you'd edited, but not the rest of it. So what I'm hoping to do, but unfortunately I only discovered I was using a Macintosh. It's not going to like that, is it? But it might like that. No. Alright, we'll skip that bit. I thought that might happen. I can show you on my laptop afterwards in the pub. But it had all this stuff about saying relative to line such and such. And also, it's a parser based on operator precedence. So instead of telling you what the next character should have been, as Yak tends to do, it says what it last looked at before it got to the bit it didn't like. And it's quite interesting when you play with Western Algol, remembering what life used to be like. And it's all on the website. You can have a go with it yourselves. Now, this is what we started with. That's a line printer listing. That's the very first page of the translator. That's the first page of the controller, which somehow hasn't been cherished quite so much as the translator. And that's the very last page of the lot, which had been cherished even less. We got some manuals as well. That's a photograph of my bookcase at home. And we've got some human memory. We've got willing volunteers, especially Brian Witchman. And we've got a web page listing the order code. The importance of this, that's that many people have read that and commented on it, and we believe it to be a very accurate description of the KDF9 order code. And we got an assembly for most of the user code that I wrote by using Yak this time. Not the most efficient use of Yak, but it works, a treat. We didn't have a KDF9 computer. Distant memory, that's a real one, not the pretend one that was from a sales brochure that Brian Randall showed. And we didn't have a paper tape reader either. But we, just shows it a genuine picture from the time. And we didn't have KDF9 special characters, and there was a fair bit of debate about how to deal with those various characters. And of course, the KDF9 FlexWriter, the underlying key didn't advance the carriage, and so you could actually type things like that. But we took some early decisions. OCR was never going to work on that listing, so we had to do copy typing, which wouldn't work unless you had 2 people typing. And then we had to do automatic comparison between versions, because a person looking at 2 listings is never going to get it right. And we took some early moves. Brian photographed the whole lot, page by page. What a hero. 84 pages of the translator, 153 pages of the controller, 7,000 lines of code in all. And we had some volunteer typists. Graham Tull, who's somewhere in the Midwest of the US of A. Roderick McLeod, who I from the time thought was in Australia, but turned out to be much more remote than that. He lives in the Orkneys. Brian Witchman, who lives in Wokingham, and myself, who lives in the Yorkshire Dales. But we were the sort of maid people who worked at it. And the photos were delivered to the typists in batches of 10 pages. And I concocted an ASCII representation of user code, because of course user code includes some of KDF9's non-ASCII characters, and the typescripts are then emailed to me. And so, chez moi, I tarted up my assembler, which originally was designed to work on the director, and put some extra bits in. I wrote a program to canonicalize, though I misspelled canonicalize at one point, so that different people's styles of typing could then be compared with the diff command, the Unix diff command. And each flag difference I then checked against the photographs which Brian had written to a CD and sent to me. And it was perhaps a labour of love, but we also had an emulator being written by Bill Findlay, based sort of on the engineering of the machine, obviously going to be a very thorough emulator, but frankly, I needed to see something working to get the motivation to do the 153 pages of the controller. And so I produced a crude rough and ready emulator, which is the one that just ran Knuth's GPS test. And it soon started to work. In fact, amazingly soon. Both Bill and I can run the translator reliably and other stuff as well. But Bill doesn't want his emulator to be seen in public yet. So what about the controller? Well, around about page 100, 53 to go, our fingers started to tire. And so we had a plea for volunteers who would do 10 pages. And an army, well, not quite an army, but not even a platoon, but a few old KDF-9ers answered the call. And the final piece was a duplicate copy of page 100, delivered by Brian on 7:49 in the morning of the 1st of December last year. But there were some glitches in this process. It wasn't quite as smooth as you perhaps may have. Brian left out 2 pages by turning 2 folds at once, and it was page 13. It really was. Now, amazingly, one error was duplicated by both typists. Fortunately, it was only the 20th instruction of the translator, and I was still single-stepping my emulator at the time, because not only did they both make the same mistake, it was still valid user code. Because it's got lots of potential for these. As Brian Randall said, it's not the best assembly language in the world. And then on the 22nd of April, our noble leader, that's Brian, lost heart and sent me this email in relation to page 19 of the translator. We'd got to 19 pages, and he says, I must say I'm concerned about getting it working, since the code seems very difficult to understand. Where is it? Just next time, do better. We have the book, but there's a big gap between the two. I did make changes myself to the runtime MPL version, but that is much easier to understand. Looking at the code, it's quite clear that it predates Dijkstra's famous paper about go-to statements being harmful. But the software that we concocted, the assembler and my rough and ready emulator, were both written using multiple editing of the order code web page. The assembler was to take that web page and turn it into YAC input. And the emulator, I took that web page and produced from it a program which then spat out the ginormous switch statements, just like I'd used for the emulation of the 1900 that was used in the recreation of George III. Because, of course, little tiny errors look like hardware faults in this game, and we all know as software people that hardware faults are, not good news. Meanwhile, Bill Findlay is writing his emulator in Ada 2005, and as we know that Ada is a language for critical systems for reliable programming, we should have no bugs there either. Let's have a little dose of nostalgia. Well, user code is quite the worst assembly language that I've ever used, but Brian Randall tells me it's not as bad as Dukes. KDF9 instruction set, on the other hand, is quite a masterpiece. We had some email debates about the nesting stores, which were very clever, but perhaps we'll have a KDF9 session and discuss that another day. We didn't put enough comments in our code. I'm absolutely ashamed to see how few comments I put in my KDF9 code at the time. And I've got some listings of stuff where the comments are picked out in red, and they stand out by their sparsity. You see, we didn't understand software maintenance. It was still thought to be quite kudos if you wrote a program that worked properly and baffled everybody else. Dramatist personnel, who deserves the credit? Well, the master of ceremonies was Brian Witchman. He kicked it all off, really. And he did farmed out all the listings and organised who did what. The core typists were Graham Tull, Roderick McLeod and Brian himself. Most of it's been typed by them. I did the conflation of the and duplicate versions, wrote the assembler and my emulator of sorts, which you saw earlier. And the proper emulator is happening with Bill Findlay. But there were others. And we had late entry typists. And Michael Poole also provided a listing. I suppose it's all his fault, really. And then authentic linked with the past is is Brian Randall. So we now have a machine-readable source of the translator and the controller. We have an assembler. We have active listings of translator and controller where all the subrouting jumps are hot links to the subroutings. So it's actually quite good for following the code. Brian Randall emailed me on seeing it. Yes, just 47 years too late. We have binary images of the translator and the controller. We have a proof of concept emulator. We have a bells and whistles emulator project, and we actually have a working KDF9 Western Algol, and it's all on the website. You can have it for free. Duplicate copy typing can deliver accurate code. It's best to have typists who know or at least knew the language being typed, no arbitrary rules for the typing, the conflation does the hard work, don't lose heart, it will work, but early emulation is needed to motivate the sheer labour and make software tools to aid the drudgery. So you can download it all from there. There's a link on the CCS website. The double error, incidentally, was this R equals RI7 was typed by both people as equals R17, which says overwrite the code at label 17. Not a wise thing to do. It should have been that. But that's really finished. A few photographs and manuals and things, but there you are. If we go to the pub afterwards, we can see all the error reports and stuff like that. It's quite good fun.
Thank you, David. I now finally introduce Peter Onion. His website shows that he is a person of diverse interests. He builds and flies model aeroplanes. His interests in flight extend up as far as autogyros. The website also modestly states that he's interested in the old British computer called the Elliott 803. Recently became the leader of the CCS Elliott 803 restoration project, and he's determined to get the 803 at Bletchley Park working. Peter.
Thank you. I'm not old enough to do this, you know. I should add that I first came across the 803 when I was at school in the 1970s, so I'm pretty much contemporary with the machine. What I just want to do for 15 or so minutes is run you through what it was actually like to use the Algol compiler on the 803. A little bit about the 803 to start with. Machine in the early 1960s, so core store, 8K words, 2 instructions per word, so it's effectively a 16K instruction machine. I don't think we could possibly fit an Algol compiler all in one go in 8K instructions, and 16K it's doable. It's not particularly fast, about 2,000 instructions a second for the simple integer. Basic floating point hardware, paper tape input at 500 characters a second, output 100, or direct printer at 10 characters a second, and you've got no operating system with it, you've got the bare hardware. You've got a very simple bootstrap, but no operating system to help you along the way. So if you were lucky enough to get to operate a machine and you wanted to do some Algol programming, the first thing we had to do, of course, was load the compiler. It's split into 2 tapes. Tape 1's about that diameter. One of the 2 things I forgot to bring with me this morning was the 2 paper tapes. Tape 1's about that diameter, tape 2 slightly smaller. They're 903 ones.
They're similar.
So tape 1's got both the passes on it. Tape 2 has another copy of pass 2 and all the run times. As you can see, it takes about 2.5 minutes to actually load the compiler. And it then takes you another 2.5 minutes to wind it all up again afterwards. Of course, that's when that's when you really upset the real operators by ripping things, you know, when you're running them over. Just to give you an idea, the unwound, unspooled tape fills an 80-litre plastic rubbish bin. The bins on the paper tape station on the 803 are not big enough to hold the compiler, so you need a big bin to hold it. How does it sit in store? Pass 2 sits at the bottom of store, and it's about 320 words. Then the biggest chunk is pass 1, which is above it. And then the runtime sits at the top of store, which leaves you with about 2,000 words in the middle for the compiler's workspace and for your program to sit in at the end. So, not a lot of space, but it would run in load and go. So you could run successive compile, run, compile, run, compile, run without having to reload the compiler. So if we're running in that mode, pass 1, read your tape, and it produces an intermediate version called the own code, which sits in the free store, the free space, but works from the bottom up. So it starts filling it at the lower addresses and fills that space up. And then pass 2 reads it from the top down in reverse order and writes the program in the space that it's leaving from the own code that it's used, if there was any space. And for a small short program, you know, the own code would be down at the bottom and it would write the code at the top, and it wasn't a problem. And after it's done that, the program is ready to run. And the compiler produces a 2-tone warbling noise, which when I played Jeff the 2-tone warbling noise from the 803 lecture earlier, he said, no, that's wrong, it's going at the wrong speed. No, that's the real machine. I'm afraid memory may be playing a little trick there.
Right, hearing might have been.
Ah, right. So as I say, we get the 2-tone data rate at the end of the compilation. You start the program running with a press of the button on the console. No sort of command language or anything, it's press the run button.
It's the first time I knew we had a tactful compiler.
Sorry?
It's the first time I knew we had a tactful compiler.
Tactful.
Tactful.
Intact.
Oh well.
Leave the compiler intact. Ready to run. So if your code and its work variables all fit in the free space, the compiler is left tactful. Obviously, larger programs will overwrite bits of the compiler, because if you declare big arrays, it will allocate the space that the compiler sits in to hold those arrays, and you'll get the annoying re-input tapes 1 and 2 message at the end of the program. This, I believe, tended to annoy operators if you were running a bureau service. If your program regularly produced the re-input tape 1 and 2 message, you were relegated to the end of the job run. So, as I alluded to earlier, pass 1 could run out of space for the own code. In which case it would dump a binary version of the own code out to paper tape, which would obviously allow it to compile programs that needed more space for the own code than was available. If pass 2 runs out of space, it does a rather clever trick. In that, you remember I said pass 2 sits at the very bottom with pass 1 above it, and then the own code above that. If, as it's reading the own code, the executable catches up, it runs out of space. It copies all the own code down over pass 1, and then gives it a bigger gap to run in. And I've got a couple of programs that actually do that. Obviously, of course, at the end of it, you've destroyed pass 1, so its re-input takes 1 and 2 time again. So if you've got a large program that's going to go to paper tape for the own code, you can actually start off with that assumption. And you only need to load the tape 1 of the compiler, and it will produce the encode to paper tape, which, remember I said the encode is consumed in the opposite direction it's written. You actually wind the encode tape up as it comes out and feed it back in backwards. This was a clever trick because the compiler writes a certain amount of summary information at the end of the encode, which it then starts off with pass 2 reading it, so it knows some of the useful things it would otherwise have to deduce. Like I think actually how big the executable is going to be. I think it already knows how big the final program is going to be when it starts pass 2. So if we're running in encode mode, we do pass 1 with tape 1, we then load pass 2, which uses the copy of pass, sorry, we load tape 2, which uses the copy of pass 2 that's on there, reads the tape backwards, and then we run our program. 30 to 40 lines a minute. It's not fast. It was probably fast for the time, considering the size and speed of the machine, but it really, really chunters through. You can watch the tape sort of reading character by character. What's quite interesting, some work I've done with the actual 803 collection recently, with some enhancements, I've actually got it printing out on a PC screen the text as it's reading it and compiling it. So you can see it reads some symbols and doesn't take very long thinking about them. But other symbols it'll read it and it'll go away and think for a couple of seconds. It's obviously got bigger tables to search to find the symbols or whatever. It's quite interesting to watch it. What are the things that actually are difficult to compile? And then pass 2 takes, as I say, about 3.5 minutes for the largest in-core encode. So if you fill the whole of the free space up with encode, it takes about another 3.5 minutes. So you can quite easily spend 10 minutes on a single compilation pass. Of course, you then discover that there's a bug in the program, and it's another 10 minutes round the loop. Yes?
Just make a point that the Elliott system did exactly the same as the KDF9. It did, after finding one error, it did make a pretty good fit.
Yes, I've got a bit more to say about that, I think.
Yeah.
One way we can speed the compilation cycle up is what's called a precompile package, which will actually dump out the encode from pass 1. Not only does it dump the encode, but it saves the compiler internal state as well. So you can compile a chunk of code, put a precompile statement at the end, and it will then save the state of the machine. You can then reload that, which is a binary tape, so it reads quite quick, and you'll then, as if you've just compiled the last statement of the previous tape. So you can then put your own use of functions that have been defined earlier on the end. So it was sort of like a very crude early library type function, but you couldn't load more than one precompiled tape at a time. But you could, of course, take a core set of functions, put your own on the end, and then have another precompile statement, which would now give you another precompiled tape with some extra features on it. A couple of example packages that came from Elliott. There was a plotter package, which had straightforward sort of move, draw, and would actually write text on the plotter as well. And there was a matrix package, which had got some fairly optimised memory usage functions in it for doing matrix stuff. The nice thing about both of these, and the compiler itself, and like the work that we've just heard about, I had the tapes. I had preserved copies of the tapes. So there was no reconstruction, no rebuilding, nothing to work out. It all just existed already. Right, the debugging cycle. Going on to what Jeff was talking about just then, the errors. It was purely numeric code. So for example, if it came across an identifier that was not declared or used outside the scope of its declaration, it would print error 20 and the name of the variable. But it would then, as Jeff's just alluded to, it would carry on doing syntax checking for you, but obviously not produce a runnable program at the end. I've yet to produce error 49, but I love that. Program too large or complex to be compiled at all. And that's actually what it says in the manual.
Whetstone Algol is more modest. Its equivalent says KDF9 too small.
I like that. So one of the most useful things in the debugging cycle is actually your soft pencil that you, because when it comes across an error it stops. So you take your pencil, put a gentle mark on the tape and let it carry on. We then take our program tape, which might be quite long, to our 10 character a second creed editing station. We find the mark, we put it in the reader, we print out the line and we say, oh yes, I can see what's wrong there. Obviously for a short program it's practical to run the whole thing through and edit it character by character. But the manual clearly says that between every statement you should put 3 blank characters. In fact, it goes as far as to say that the statement's termination should be apostrophe, not semicolon, apostrophe, because Eliot Jellicoe didn't have semicolons, apostrophe and 3 blanks. That allowed you to take your uni-punch, which is a punch block and a single punch pin, and punch the dollars character, which I think is 5, before the lines with errors. And the compiler would stop and go into a system's wait at that point. So you take your tape out, put the line, corrected line in, which again ended with dollars. Press the button, it read that line stopped, took that one out. Went one statement on in the table. Carried on.
What's wrong with razor blades and sticky tape?
Oh, well, this is the official way of doing it. This is what it says in the manual.
It's interactive editing.
So, of course, we've actually we've actually managed to compile our program, but we haven't got a correct tape. At which point you can take your sellotape, sticky tape, and scissors. Or we can manually edit it together with the creed editing station at 10 characters a second. Or there was a program called C14, which rather cleverly doesn't overwrite the compiler by sitting in the free space. And that was an early stream editor, like it said. So you produced another tape which has then got commands like find line, delete line. So you compiled, you produced an edit program which C14 would then read. It would then read your tape at 100 characters a second and punch out the modified version at the same time. So as you can see, using the 803 compiler is quite an experience. It's a very hands-on, very manual thing. It's a very rewarding thing though, actually, to actually see the tape chuntering through. Since the middle of this year, the 803 at Bletchley is running the 803 compiler again. We got the second store working. We did some work on the tape reader to improve that. So it does run. It does make the right noises. And I'm trying to get Jeff and Tony to come over sometime this year and see it. As it says, any questions? Yes?
That reading the tape backwards is cleverer than you've said it is, because not only at the end of the whole tape you get a summary of the whole program, which you see at the start of the next pass.
Yes.
Bearing in mind Algol is a highly nested language, at the start of every procedure, at the end of every procedure as it comes out, you get a summary of the properties of that procedure, which is reading at the start, how many nested blocks there might be, and so on. It's actually a very, very powerful technique.
It's dealing with the jumps and what's easy too.
Yeah, yeah.
Know the destination.
All is.
And it's quite good fun. On my emulator, I actually get a visual display of the store, and you can actually see it writing the code down from the top, and the program being written from the other way around.
When did the 803 first start working? Because it seems incredibly slow compared with the KDF9.
The 803As came out in it says in the manual, references to machines completed before the 1st of December 1960 should be taken as 803As. And machines after that date were 803Bs.
Oh, I see. So it's quite a bit earlier than the KDF9.
Yes.
It is a serial machine.
It's a bit serial
Oh, I
machine.
see. That's correct. Yes.
But it worked very well. What did you write the emulator from? Just a description, a detailed description? Or?
Yeah, I mean, I started the emulator when I first got a 286 machine, so you can see how long ago that was. The 803 is actually a very simple machine. Obviously, you don't. Well, at that point, I didn't do a bit serial emulation of it. You do a 39-bit parallel machine implementation of it. But the instruction set is very regular, and there's not a lot. The most difficult bit to emulate is actually the floating point.
It is regular. It's not peculiar that it has odd side effects that you didn't know about.
Not really. No, it's a very straightforward machine. To the extent that you can, with about a one-page description of the instruction set, you could write an emulator.
Can I invite people, Otto just had his next comment,
Well, I just wanted to say,
to ask any questions or any comments about the Sartre?
Yes.
the comment about the speed was definitely fair. I mean, we felt that it's still done something quite good. And as the machine was being used very much in educational establishments, the short load and go thing was a very important feature. And what helped Elliot Algol to its more success was the 503.
Yeah.
Because as soon as the 503 came along, with the same instruction, everything, paper went in at full speed, home code went on to the core backing store, and everything was fully load and go.
Yeah.
It was pretty well impossible to have a program that was too large and complicated to be compiled.
Thank you.
Thank you, Peter.
We move around the front, so I can ask a question rather than something. If you've got doing Elliot with a whole set of film handlers,
Yeah.
how, in what way is this different? Is it not quicker?
I think it would write own code to film, wouldn't it?
Install the compiler and the two parts on film, it would write the own code to film if necessary. So everything that wouldn't normally come out on the paper tape would go onto the film, yes.
And they're much quicker.
Well, yes. I mean,
The slight,
the compiling itself would be that.
No, that's the sort of
yes,
machine.
but the operating would be.
the unfortunate thing is, that was done by a thing called Algol Tape 3,
But there weren't all that many.
which I haven't got.
There weren't all that many film machines running Algol. I think the film machines tended to go to the commercial customers of NCR who used it for their data processing work.
Yeah.
And relatively few of the people, the educational establishments who bought the 803 for the purpose of teaching everybody and stuff, had film. So although the stuff was there,
I was referring to film because it was actually 35mm Kodak's floppy disk film, not plain tape.
Richard Border, then Brian Randall.
I'd like to ask a question of Mike Woodger. In reading up about Peter Landon's life, I was reading up about the United 60 conference. And one report of that conference said there were a lot of people there shouting Landon notation, Landon notation. Literally that phrase was, there were a lot of people there. There was a gang there shouting Landon notation, Landon notation. Can you cast any light on this claim?
I don't remember any of that.
Okay, so.
I think I would have noticed. Being familiar with that, the notation of that film.
Or perhaps you were part of the game.
What else do you ask? Ask John Beckett.
Brian?
My question is probably to Cliff, but I'm not sure if anybody else could help answer it. This question of the 1964 conference, which I recall are formal language description languages, when these two sets of people came together. The formalists who were interested in syntax and the compiler writers and programming language designers. I recall it as being a conference at which those two sets of minds did not meet. I'm not sure it was actually bad-tempered, but the conference took place in the middle of an Algol committee meeting. There was a bit of the meeting, then there was the conference, and then we went back into the meeting. And I think I remember in the back half of the Algol meeting, the sort of sentiment along the lines of, oh, so that wasn't much use to us then. Mike is nodding, okay?
Yeah.
The aspect of the book that Tom Steele produced afterwards, that I must admit I found most wonderful, was the verbatim transcript of the drunken, and I mean drunken speech, by Fraser Duncan, who had become completely morose during the meeting. He was due to be after dinner speaker. He disappeared for a couple of days, was persuaded to give his talk on our ultimate meta language. In other words, that any fundamental understanding involved some common understanding of typically of a natural language, in which he did a very nice hatchet job on the formalizers. So now that's a view of the conference. which doesn't match with your comments on
Yeah, definitely a couple of comments. First, I wasn't there, as you know. The discussions recorded in Steele's book, I think, are invaluable, as recorded in the book, but they may, of course, been cleaned up. I know most about the conference because the Vienna colleagues, the people I went to work with when I went to Vienna in '68, were the scribes. They were the people who'd taken the things down. I never asked them whether they rubbed out all the nasty, aggressive bits of the discussion. But as a history document for somebody who wasn't there, the discussion is absolutely invaluable. And it may be one of these things where the two groups went away and only realised afterwards what the real coming together was, what the real contribution was. So in particular, McCarthy's paper and Karl Algol's paper were enormous, and Landon's contribution, were enormous influences on the Vienna group.
Well, it was formalists who were interested in semantics, not syntax.
Yeah, I think that was a slip of the tongue. Sorry?
Semantics, not syntax.
You said syntax. That was a slip of the
McCarthy
tongue.
had a semantics paper, Van Wijngaard introduced continuations, Landon has a formal definition of Algol 60. There's lots of semantics in there.
Okay. I guess I'm remembering syntax, possibly because I'm also remembering that at that time there were a large number of people writing about syntax and approaches to syntax-directed compiling and writing papers which gave the impression that syntax was the only issue of compiler writing that mattered. When as far as we were concerned, that was the trivial bit.
So that's absolutely true of books at the time.
Yeah.
And the reason I value your book and even paid real money to replace the one that's been nicked was that your book talked about the real problems and not, as most books did, about syntax. But I think your record, certainly as the conference proceedings are, your recollection is wrong. There's almost nothing about syntax, it's all about semantics.
Okay. I should go back and look at it.
There's one little anecdote which is very little content. It echoes what you said about land gutters. There was a hush during the meeting when some fellow with a very rich Central European accent put his hand up and said, "I propose one additional notation to add to the language." And he said, "lambda." Now, nobody, or some of us knew what it meant, the others hadn't a clue. That's the only memory I have of what you described.
Thank you, Mr. Chairman. You nearly had a problem just now when you looked at Brian Randall and said, "Brian." Unfortunately, my name is Brian as well. You very nearly had a race condition on your hands.
But I wasn't looking at you.
That's true. A very small story. It's actually a Tony Hoare story, so I hope I get it right. It goes some small way to explain perhaps why Dr. Hill finds Pascal a slightly less than satisfactory substitute for Algol 60. The story goes like this, that when Nicolaus Wirth had completed his first write-up of Pascal, and he was about to send it off to the ACM for publication, he sent a copy to Tony for comments. And Tony wrote back and said, "Absolutely fine, I wouldn't change a word, but what I would do was change the title." And the title was Pascal, a New Programming Language. And Tony said, "Well, if you actually want the Americans to take any notice whatsoever, what I suggest you do is to call it Pascal, a contribution to the development of Fortran." Unfortunately, Nicolaus didn't change the title. The Americans didn't take any notice, and Tony thinks that it probably put back the acceptance of structured programming 10 years.
George.
I was rather impressed by the discussion of Peter Landon, who seems to have been an even larger figure than I imagined. I take some pride in this because, in fact, I recruited him into computing in the autumn of 1954, and last saw him at a reunion in November 2008, and the following breakfast. So I not continuously, but certainly at the beginning and the end, I was very closely involved in his contemplation.
But they're extremely well on time. David, your last question about it.
Yeah, well, in a sense, a comment following on what was the discussion about syntax, semantics. For a time, in the 80s I taught compiler writing because nobody else was prepared to do it. And I'd also written the Fortran compiler that we used on KDF9 timesharing. And I was always struck by the fact that the great bulk of the textbooks focus on syntax to start with. And I always think the right way to do is to look at the object code and how you're going to map the semantics of the language onto the machine code that you're aiming at. And I got partway towards a book called Understanding Compilers Backwards, and I think it might have been quite worth doing.
Thank you.
Can I say one final point? The work that we did, that David described on reconstructing Whetstone Algol, was really only possible because one, Michael Paul, preserved the line printer listing. So if any of you have got line printer listings in your loft, don't throw them away. And if they're anything to do with KDF9, then please tell me. Thank you very much.
If there's anything to do with anything, please tell me.
Brian, I'll let you have the last word.
I bet nobody else can link together Whetstone Algol and John Bacchus, but I can. The GPS, the example program which Don Knuth had designed, really to show, almost to show how impossible Algol was to compile, was one that we chose for that reason to give us the example in the Randall and Russell book. But the appendix which lists it there has a quote from John Bacchus, and I believe that it's a quote from his original paper on his Fortran compiler, if I remember rightly, which is along the lines of a single example of the running of a system is not very believable, particularly if it's chosen by the designer of the system.
Before thanking the speakers, I need to make the usual very short business announcement, which should be interesting. Our next talks are on the web as usual. Rushing through them, 18th of February we shall hear about the CBC 6600 from Dick Leatherdale and somebody else. On the 18th of March we're going to hear about the Harwell Decatron computer, which is a fascinating artifact that's surfaced and has been restored at Bletchley Park. The 15th of April may have in your diaries a talk, but we actually got a hole there at the moment, we're trying to fill it. And finally on the 20th of May we have the Pegasus at 50 celebration. That's the 50th birthday of the Pegasus here in the Science Museum. And we have announced previously that Pegasus suffered a sad fire back in the summer, but there's now movement forward, and we're now really quite confident we'll be working again by then. So that's that. Now, I think this afternoon has been absolutely fascinating. I use all sorts of words about brilliance and so on, but the word I come to be is rich. We had a rich set of speakers and a rich lot of information. And that I think we're very grateful. It's been marvellous to see Mike Butcher here. And seen for years. And the rest of you. I want to mention all of you. You've done the job superbly well, and you've done it in time. So thank you very much. And those members here of the advanced programming group who come here, you're welcome again. Thank you very much.